program, ICSSP, as we would go by. We have a little bit of a demo on some malware sort of deal, kind of complement the wonderful work SIGPwny does as well with vulnerability and exploitation. And then we can answer questions at the end about our program, but there's also a more formal info session tomorrow in the ECD building with pizza.
So basically, we came here to show you guys cool stuff, and they're on our backs about marketing. So like, we'll talk to you about that too, and also like that's also our job. So if you have questions, we're amongst the best people you can ask since we're actually in it. So we'll hit all the details of that later if you have no idea what this is.
All right, so we can get into it. Part of the SIGPwny is you look at all these exploits. You look at getting in the front door, finding some issue with some program, getting in there, doing the rough chain, all that sort of jazz. But that's not the whole story. There's other aspects to it. What happens after you get in the front door? What are the issues you see? I imagine many of you know are familiar with ransomware. That's kind of the big headlines. But there are other options, and we're going to go into another option that is very popular and prevalent amongst cybercrime. So I think if we have a little visual, so most SIGPwny falls into the vulnerability exploit, but we're going to look at sort of what happens afterwards and what can happen from there. So in particular, instead of the I just mentioned the word. The other one.
Ransomware.
Yeah, ransomware. You have the remote access Trojans, where instead of trying to be in your face, your computer's compromised trying to get money out of you directly. This one can be a little bit more subtle and just trying to get the data out of you where they value what you have on your device or your access controls more instead. So in particular, this can be used to monitor what you're doing, what you're looking at, what you're typing in, that sort of thing. And among things, since it's trying to be subtle, you can try to append this in with files that seem legitimate. So part of the phishing campaigns where you try to download a Word document, it may load up in the background something else going on. Kind of went through the use cases, and this is very common against some advanced within advanced persistence threats, where they stick around for a long time and keep within the systems and try to continue operations within. So this is common with several different ones, and then in particular, we're going to focus on the Quasar rat today, and we're going to look at more into that.
And so offhand, just kind of the interesting thing about this is if you're thinking like in a slide or two, this sounds like vaguely script kiddie-ish. You're right. It does sound vaguely script kiddie-ish, even though it was a massive pain to actually make it all work. But interestingly enough, that's like a lot of the actual hackers out there too. Like if you had actual skills doing this, I don't know if you'd be doing something else, or maybe you just wouldn't be, the person people catch. But either way, like this is something that like Chinese hacking groups, like for the government, have been caught using specifically, the thing we're going to be showing you. So it's kind of interesting that, at least we'll give you a taste of what this stuff might actually look like if someone were like really going after you, even if part of you is like, that seems kind of lazy and I expected better of them. So yeah.
A little side note on that. So I used to work on a project where we would deal with phishers and scammers. And I counted Quasar probably over 100 times. Someone trying to phish me and give me a download it. So it's very common.
Great, next slide.
Next slide.
So Quasar, what does it do? So this one's an open source one, so it has a GitHub page, which is amazing. It tries to present itself as a legitimate use case, and maybe it started that way. Remote admin tool, like you need to kind of deal with a device on your server. You need to be able to log into it, see what's going on, that sort of thing. But as you start to go further down the list, you may have more questions. Being familiar with computer security, such as remote execution and keylogging on this list, but like password recovery. So fortunately, this is on a lot of the lists of like your antivirus. They'll check for it for this sort of thing. But if you can just kind of override, turn it off, download it, it'll still function as intended. So if we have the next slide, I can show you that has the GitHub page. where it's got its own, like, it's got build passing, it's got tests, it's got a license MIT, and it goes through all the features that it can provide to your system.
It's got a list of contributors. You know, like the little profile pictures on GitHub? Yeah, it's got that. Like people's usernames are associated with developing this thing. It's great.
It leads to some interesting questions on how much they know.
Okay. Is this roughly the right distance?
Yeah.
Can people on Zoom hear me? Hopefully. Okay. Yell at me if you don't. We'll do it that way. Sweet. Okay. So what are we actually going to be doing for you guys today? Well, what we're going to do is we're going to be installing Quasar on a victim. Basically, what we're really doing is we have two virtual machines set up, one for the attacker, one for the victim. We're going to be attacking the victim. But in terms of like the actual details, what's going to happen is the attacker is going to have a server running on it for this Quasar control stuff. They're going to generate a payload, which is like sort of, they call it the client, but you know, really it's the malware, which we're somehow going to get to run on the victim. You will see how very shortly. Once that payload is delivered, it'll start up, do whatever nasty things it does. Maybe it'll, you know, change some registry keys, make itself auto run, all the fun stuff that, you know, Windows malware does. Once it's at that point, what it's going to do is it's going to phone back to the server. And not only will the server know that this thing is actually running on it, like it doesn't just beacon, the server will actually, we'll have a nice little GUI that gives us full control of the other computer. So it'll be very exciting. So yeah, Quasar, once we somehow convince the user to run it, it does a couple of things. It does some things that really beg further questions about how on earth they claim it's like a legitimate tool, because it'll do things like try to privilege escalate, like it'll just ask for admin privileges. And you know, like if the box opens up and the user says no, like it doesn't do anything. Like it's not this super sophisticated zero-day thing, but why would you do that if you weren't trying to get it for reasons you shouldn't have it? But anyway, install itself, persistence, all that fun stuff. So yeah. Next slide, we're going to talk about obfuscation a little later. That part's interesting in the sense of it'll be our documenting our struggles with getting this attack working in the first place, but I don't want to spoil that yet. So yeah, the scenario, you have a really cool Excel spreadsheet. You're going to see this in a sec.
What does it do?
There's some, yeah, what does it do? There's some marvelous macros out there for Excel spreadsheets that enable all sorts of things. Like, I don't know if you guys have heard of Arena XLS or whatever, but there's like a flat out, like you get to fight little monsters on the screen in an arena kind of thing. We have 2048. It's got like a nice like 2.5D 2048 board on there. Unfortunately, to run, that thing uses like VBA script macro stuff. So what we do is we also inject a little bit of code at the beginning of that, in addition to like being a functioning game. It's going to phone home to a server and download a payload from there and run it. So what's happening is we're going to be running a server that's hosting an exe over on our attacker VM. We basically have just like a private network between the two VMs here. So there isn't anything interesting involving NAT or like networking stuff beyond the fact that like the two IP addresses can directly talk to each other. It'll phone home to that, download the thing, you know, just like flat out GET request it and run it. Then once it's installed, well, we'll show you what happens. And on to the demo.
All right, so time for the demo. So let me switch over these VMs. All right. So right here we have the attacker VM. It's in high contrast, put high contrast so you can see the difference between the attacker and the victim VM. So this is the Quasar program right here. If it wants to look it up. All right. So for Quasar, you download it and there's an executable to run the executable. And here's what you're gonna be greeted with. You're gonna be greeted with a screen, have IP address and everything. Right now, there's no connections because we haven't built a client. So this tool is very simple. It's made for people who have never done anything with computers at all in their life. So everyone can run this. What we're gonna do is you're gonna go to Builder and we're gonna build a executable for you to find as a payload. So we're going to tag this as attacker. Doesn't really matter what you put it here. What matters is the connection settings. Whatever your machine that you're using as a hacker, make sure you have the correct host information for that and the port you want Quasar to work and call back to. So from there, this is where it gets fun. So to install a client, you can choose where it's installed. You also can make it install as a hidden file. So once the file is downloaded, they won't know it's there. They won't have any idea where it's stored unless they have a few hidden files on, which most people don't have. And just what you want to name it. I think a good name for this is Totally Safe Program. And there's other settings you can do for it. Just if you want keyboard logging, because if you're a remote desktop administrator, you definitely need that for legal reasons. And just information, you can change the copyright, the company name, description. This is definitely not a rat, things like that. So what we're going to do is we're going to build that client into a server that we have hosted. I'm just going to save that. So that's going to be it for the attacker. We have the client payload saved. And now we're going to switch over to the victim. I apologize for the lag. I'm like hosting this on a computer that's somewhere else. All right, so here's our victim PC. Everything's nice here. Everything's happy. And they really like 2048. So they got an Excel file that runs 2048.
Yeah, it's like, there aren't really animations, but it does play the game, like they merge and everything.
Did you write this yourself?
I did not write it myself. In my heyday, I was a batch programmer, but I never really escalated the VBA before I learned the real language.
Right. All right, so 2048, really fun game, right? So in the background, what happened, and we're gonna look at the file. It actually, so who here knows about Windows Defender? So if you disable Windows Defender, they changed in a recent update that automatically enables itself when you restart the machine. So for Quasar, it's one of the most common antiviruses in the world, or malware in the world. So everything detects that. So for this demo, we had our antivirus turned off, but Windows said turn it back on. So I'm going to turn that off real quick.
Were you running the Python server too?
Yeah,
Or
it's just Windows said no.
again?
So this is a reminder that your computer does a very good job at protecting you.
Have your
Or a lot of-
antivirus on.
From the very, so a lot of the time when you're trying to do these demos, you have to turn off a lot of the safeties to even just demonstrate the very basic of, I would like to have this show up and be on my device.
But also, Grant will be talking about later, you can get this past antivirus. You want to take like the script kiddie approach. Like if you're a tech support scammer scamming someone, just gonna ask them to turn off antivirus. All right, so there we go. So we have this program, it just ran. We're going to show you the macros that we actually added onto it. But you see right here, this client file that was created. So what happened is the macros we made a wget request to our server, downloaded the client, and it executed it. So did anyone see anything weird happen to the computer while we opened the Excel file, any flashes or anything? Nothing weird showed up. So how do we tell that something's going on? We're gonna look at Task Manager, and I believe there should be a program running called Not a Rat. Does that look suspicious to anybody? So now we're gonna switch over to the attacker again. And look, we can see the location, we can see victim's desktop name, the version they're running. And that's all cool, but now what can we do? Well, there's different categories we can do. We can open the file manager, we can remote shell, we can do all of these things. We can monitor, we can look at the key log for it. So right now we're gonna remote desktop and see what this does.
Give it a sec. It's a remote desktop within
It's a remote desktop. So we can see everything they're doing and they don't have any indication that we're doing this at all. Another thing about Quasar is it's persistent. So once they reboot their computer, turn it off, it's going to be there because it creates a registry file. And there's no passwords on this VM, but you can extrapolate Google Chrome passwords, browser passwords that are stored in plain text. You can get all kinds of files. You can run more commands. Once they're on, you can send your own script. Say I have a more malicious payload. Now I know I'm on the system. I can send all of that. I want to use the keylogger and we'll see what happens, what we get according from there. All right, so let's just open up victim again. And let's just type. And let's see how that shows up in Quasar. So searching for H. Is there any functions that looks interesting on that they like to see? So you can view the computer remotely, you can keylog, you can execute more, you can send it to websites, you can force it to do different things. You can also uninstall your malware because you're a nice person and you don't want any tracks left. You can escalate your privileges, you can update your connect. You can also, if you have multiple clients and we don't have them for sake of RAM, you can make them ping each other until one of them crashes. Any questions on this?
Quick question, is this program typically detected by antivirus, or is it because it's like open source remote management? It's like,
Oh, it comes out.
it comes out.
We tried to download the server, like, so you don't download like the malware, right? Sorry, you don't download like the client that, you know, we had to like go through the whole macro and like hidden server running thing. You download the server and then like it basically compiles its own client that's coupled to it. It didn't like the server. Like we had to disable a bunch of stuff on the attacker just so that it would not automatically delete that file when we tried to download. We're going to get into some interesting stuff with antivirus in a sec, but yeah, this one's common enough.
This is, if not the most common ret, one of the most common rets. Interesting thing with NVIDIA hack that happened, like I think early last month, they actually signed Quasar with NVIDIA certs and it worked for a good 24 hours before people realized it's Quasar.
Wow.
So if there's no more questions on demo, we're gonna go back to the slides. Any questions, anyone in Zoom either? Okay.
So this is a reminder, like ransomware is kind of the end result, and this kind of gives you another way to branch forward and kind of do whatever you want. You can
Go one up.
Yeah, you could do your remote execution or whatever you want to do. Typically, within SIGPwny, you look at just kind of the front door and then what you can do after that.
So yeah, I guess speaking of that, so like we had a lot of fun doing this, but you know, pretty obvious, this was like a pretty stripped down attack, right? Like we had to disable a bunch of antivirus stuff on the victim to get things running at all. We had to get them to like stupidly click a macro thing that they had like no good reason to click. Although people do that all the time. So that part's reasonable. The part where like Windows didn't say, no, you aren't allowed to do that after that, we had to force. But the relevant thing here is that we wanted to show you, like Hamilton was saying, kind of the post-exploitation chain of what happens. And so we got you a really stripped down one. We actually tried to go a little further, and we're going to detail sort of where we fell short. And an interesting thing there is sort of, so like the very basics of this are very easy. Like there's plenty of people who, you know, are not particularly competent and are more than capable of, you know, scamming someone into running this thing. The interesting thing is when you want to take this and actually like really use it against a target who like has any notion of security. And that's where we ran into some trouble, and it's very doable. So we're going to walk through how we would have done it if things hadn't like gotten really painful for us, and you know, some lessons learned along the way. So we'll start with basically like what CS461, if you've taken it, would give you in the slightly less technical section on like intrusion detection and like malware detection, you know, like all the whatchamacallit, like syscall tracking, diagrams and all that stuff. But just to give you a quick idea of sort of what we're up against and then which parts really matter and how we can circumvent them. So starting with as Windows as the host and whatever, there's a couple of ways that this thing gets detected from like the actual host operating system, not the network. We'll get to that in a sec. So from the host operating system, the simplest way is signature based. And for something like Quasar, that's like more than enough. We'll get into like how you might get around that. But like at the basic level, this thing has been used so often. Like it's literally open source, anyone can compile it. Like even if they didn't get, you know, a file signature from someone who got infected and then they found it. And yeah, Windows yells at you, right? The problem with signature based is while it was good enough to keep us out for this kind of initial basic attack, it's pretty brittle. We're going to get into that in a sec. There's plenty of ways that you can obfuscate files. The easiest thing to do in terms of obfuscation is getting around the signature based. The other ones are going to give you a lot more trouble. We'll get into that in a sec. That being said, Windows Defender seems to largely rely on this. Like Windows Defender had a lot of problems with this file existing, period. It did not have very many problems with this file doing things like opening remote connections on weird ports and sending data, or, you know, creating remote desktop sessions, or any of that kind of thing, or even trying to like install itself to auto start. Like a lot of that stuff, it gave a lot less trouble in general, a lot less alarm bells went off than just the existence of the file, which tells us something about how signature based, at least this basic version is, right? But if you want to escalate sort of how you're detecting things past that, because as we're going to get to in the next slide, this is the easiest thing to get around. There's more behavioral based monitoring for this kind of thing. And the tricky thing here, right, is that like malware like this, no matter what the actual source code, no matter what the assembly instructions that it compiles it to looks like you encrypt it, you decrypt it, you do all sorts of weird permutations on the code that like semantically ends up with the same thing, whatever. That doesn't change the fact that it has to do suspicious things, and those suspicious things interact with the operating system. Like it still has to create files, it's still has to read files, it has to like create a socket and connect. All that stuff is still going to have to happen. So if you get clever about how you can track that and monitor it, then you can still detect these sorts of things, even if they evade the signature-based stuff. As we said, this didn't seem, a lot of that wasn't happening with Windows Defender, but that would be very good for like kind of the next level of defending these things. And then if you wanted to go a little further, you've got like the fancy heuristics rules-based stuff, which is basically just kind of a generalized approach to that syscall monitoring. So that's the host based. We're going to get to that in a sec, but there's another sort of approach to this, which is network based. So on one hand, this thing has to like, you know, run on a host, and it would be great if that host could, you know, detect it before it installed itself and all that. On the other hand, like this thing has to take a path from the outside network to the host, and then it's probably going to call back out after for all of that, you know, control server stuff. Every time we click, there's some packet that's going back and forth, right? And so for all of that, that's something that you can also monitor, obviously. Interestingly enough, this software is like decently written enough that's like actually sends encrypted packets. Like it does use HTTPS for like the to and from stuff. But that doesn't mean that, you know, there aren't signatures or weird anomalies that you might be able to see there. And we're going to get to that in a sec. But this is also something that, you know, it's not unsurmountable. There's clever ways you could smuggle your data out in various ways. So like if someone wanted to like download all the files off of our VM using this thing, you know, like trivially, you'd be like, huh, like the bandwidth spiked at 3 in the morning. I wonder why that is, right? But there's ways to smuggle your way around it. You know, like I think I remember something clever about like hiding things in DNS packets and all of that, you know. Then, you know, it's a cat and mouse game of, huh, well, do these DNS packets look weird, whatever, and, you know, keep going back and forth, trying to find ways around things. Maybe you're looking for like organizational blind spots more than you are like actual vulnerabilities, if that makes sense. Like you're looking for a silo between like the two teams that manage two networks, and maybe they don't really look at the connection between them because they both think that the other person's in charge of it. And then like, it's almost like an anthropological approach to attacking things. But either way, the point being, this is something else that you're going to have to deal with. And now we're going to talk about what we tried and failed to get around these things. So, obfuscation. First, we tried the ScriptKitty approach because we didn't write the malware ourselves. So like, it's kind of hard to like hand roll something when you only have the executionable. It makes it harder than like if we were using a compiler, and then we could like really do the clever tricks, right? So the first approach we took was we were like, so like a common thing that malware does is it basically, like encrypts itself and then just like includes a little bit of code that runs a decryption engine. And it just like passes like the rest of the file as an input to it, like decrypts itself on the fly and runs that. And we were like, okay, there's something like a little less malicious than that exists, but that's like functionally the same thing. And that's something called UPX. It's like basically an unpacker. And what it does is it's to save space on your binaries, you might want to compress the binary, and instead of like an encryptor, you have like a decompression engine. So like some languages like Go have a nasty habit of sometimes creating large binaries. So like there's reasonable reasons that aren't because you're a malicious attacker, but your software, like so the user doesn't have to like fill up their disk space unnecessarily, is including this kind of software is like a preprocessor before the stuff really runs. And it accomplishes the same general idea of obfuscating the actual contents of the code, because now like the only thing you can really see is the UPX stuff, which legitimate stuff has. And the malicious signature-based stuff that you would be hashing over or whatever is like this entropy-full thing, just like it would be if you encrypted it. Unfortunately, this is a .NET project, so it isn't quite native, even though like it's an EXE. And UPX doesn't like that. So that was a very long way of saying no, that didn't work. We tried some other tools unsuccessfully, partially because we were hamstrung by the fact that, like I said, like we couldn't actually play with the source code as easily as like if we'd been doing things from scratch, and partially because, unsurprisingly, I'm sure like everyone's tried these before. Like if people are downloading this thing off of GitHub, you're telling them that they aren't, like the next thing they do is like go on GitHub and look up .NET obfuscator and then like run that through it. So your script kiddie just like running things. The UPX thing just like the thing didn't run, but the rest of them, even the ones that like actually worked, Windows Defender saw right through it. That isn't too surprising. That being said, there are some really clever obfuscation techniques that, if we were really going at it as sophisticated attackers, and probably if we've been actually like hand rolling our own malware, at least to an extent, present very exciting opportunities for doing this. So like the basic thing would be encryption, right? But Windows has all sorts of like wacky ways in which like binaries can get linked and like reassembled when you run them. So there's some very interesting obfuscation work that we happen to see involving like basically messing with the loader and like kind of mutilating the file and then having it string it back together at runtime. And that's the kind of thing that should get past the signature-based approach, at least if you like mutilate it beyond no end. Same thing if like, you were to do something nasty, like rewrite the whole thing in terms of move instructions and like weird semantics on those in terms of the like offsets on addresses and all that. So the point being, like, if you're clever, that's something that, like fundamentally there isn't anything stopping you from getting around it. Like someone's going to catch on to like whatever you did, and then you have to come up with something else and so on and so forth, whatever. The interesting thing though is that while that's doable, behavioral patterns are a lot harder, even though, as you saw in this case, it didn't even matter. And the problem with behavioral problems is you still want to do suspicious things, but you don't want to look suspicious while you're doing them. And the stuff that's monitoring syscalls, like they get to see all the suspicious things you're doing. So, like up front, the way you get around this, like, I don't want to say brute force because it's also elegant, but like it'd be a rootkit, right? Like you just flat out throw something really good at this that like actually uses a real exploit, and nothing can actually track its syscalls because like it raised the entire thing into like a VM and it's running its own weird hypervisor underneath, right? But if that kind of thing isn't happening, you're going to have to find something else that's clever and that actually gets around this, because to a certain extent, you could like change the pattern of like the order in which you open files. Maybe you could do something clever where like you figure out that you can execute a program that like, if you give it the right input, it will write to the file you want, doing the thing you want. And you like do some kind of like smuggling of syscalls through other things. So like there's options for you, but you still have to kind of do the same thing anyway. Obfuscation is tough, even though you can probably get around this. And the same thing kind of stands on the network side, right? So we, due to like memory limitations, we didn't end up running Wireshark on this, but like this is a client server application. Every time we click and send it a command, like packets fly back and forth. fortunately for Quasar at least, like the packets are actually encrypted, but that doesn't mean that like the fact that packets are flying back and forth from these weird ports shouldn't like stand out to anyone, right? And B, even if they do, CISA actually has a wonderful page on Quasar because of how like well used it is. And they include all sorts of fun things, like the fact that it has a tendency to include like a 4-byte payload size unencrypted before the payload that's encrypted for whatever reason on the first connection. So there's all sorts of like pattern-like things that you could probably see if you were looking for those. Again, this isn't something that you can change. Like you're like, okay, they're onto this, so you know, I changed my format a little bit, and like that fools the regex that they're running against our packet, their packet captures, whatever, we're done. And then they catch you again, and then you have to do that again. If we're talking like, you know, the fancier ML-based anomaly detection stuff, then you have to get a little more creative, right? In terms of, you know, smuggling this in, like I said, maybe like in DNS responses, there's like the extra information, you encode like the command or something. The point being, there's options, but this is also something where the defender has a lot of visibility to what's going on in the network if they're doing their job right. So you have to try pretty hard for them not actually see anything too wacky. And I think that's kind of the bulk of what we had here. So in the spirit of things.
Yeah, so just a quick look over some other perspectives. But we can answer questions as needed. But there will be a full info session tomorrow for the ICSSP program. Tomorrow, just a few quick details. This is a full tuition scholarship. We're targeting juniors and seniors. It has a corresponding service requirement within the government in a security-based position for a similar amount of time that you do the scholarship for, and you must be a U.S. citizen. We can answer questions about the experience being in the program, what we sort of do, and anything else, but those questions will also be available
With pizza.
Yes, tomorrow at the info session.
Okay.
So yeah, thanks for your time. We hope you liked us frying some VMs for you. It was a lot of fun. A lot of big files being moved back and forth for this. Yeah, we hope we gave you an interesting perspective on kind of what happens. The initial exploit is, if I'm being honest, it's the most interesting part to an extent, right? But like, once you start wrangling with the complex systems of like actually getting done what you want to get done, there's all sorts of stuff out there, which like also opens you up to some really interesting techniques beyond even just like the vanilla kind of privilege escalation, lateral movement stuff. And yeah, we just wanted to share that with you. And yeah, also questions about this. It's awesome. We're happy to talk with you about it. We're here because we want to be. So thank you.
Give it up.
Free pizza.
Yeah.
Did we mention that they'll be unhappy if like people don't finish the pizza? So like you guys should come for pizza.
Even if you're not interested, it's come for pizza.
Sounds good.
It's an ECB, just to be clear, if you didn't see that, because I would have assumed Steve will have been wrong.
Yeah,
Sweet, we'll do that.